Okay, let's start. Hello guys, my name is Sergey. I am Sitecore developer from Brimit. This year I was also awarded Sitecore Technology MVP. And today I want to tell you about semantic search, compare it with traditional search, and also show you some test cases when and how you can use it in your working solutions. Okay, my agenda is very short. First of all, I want to have a small overview about traditional search problems. Then I want to tell you about semantic search, explain what is it and how it's work out of the box. The third part of my presentation will be overview of a very famous algorithm developed at Google. It's named Word2Vec. And in the end of my presentation, I will show you a short demo how we can use semantic search in Sitecore. And of course, I will be glad to answer your questions if you have. Okay, let's start. Because we start, please put your hands up who know how semantic search works, or maybe someone have experience with semantic search. Oh, two, okay. Okay, the main problem is you can very often face it with this. It's keyword matching. It also is known as zero search results. It very often happens when you try to find something, but for example, you don't remember how exact is the name of entity that you want to search, or maybe if you forgot correct spelling of something that you want to search. And just a demo. I hope all of you know this website. It's our famous food delivery service from Minsk. As you see, they have 250 restaurants, but for me, I very often try to search McDonald's. And as modern person, I want to use the search bar to search McDonald's. For me, it's very annoying to scroll over the big list of items. And maybe someone can guess what search keyword should I use. And see, I recorded the video, and let's see. I tried to find by MC Donald's, and as a result, nothing. And for me, it's very annoying, really. But as you can see, McDonald's is present in the list, but you can't find it. And this is a big problem for real solutions. But as for me, if we have any other this good delivery service in our country, I will use them only if they have a good search engine. The second problem is also obvious, but unfortunately it can be solved in traditional search. For example, if you find something, for example, if you try to find word modem, but in your index there are no any text with this word, but if in your search index present some words, for example, link router, you never find some relevant results if you will search with word modem. It's obvious. And also, if we, for example, trying to find something like eat banana, we will never find text that contains like pineapple. The second problem is not so obvious, but you can face it. Also with it very often, the problem is named irrelevant results. Very often it can be faced when your search phrase contains keywords that has homonyms. For example, if you search for Switch watches, you can get the first top relevant results like Alex Watch TV. Logic presents, but results are irrelevant. Okay, in traditional search there exist some solutions that you can use for to make your search engine logic more smarter. You can use fuzzy search is the simplest one, or if you now in Sitecore 9 and higher, there are present spell checkers and suggestions for Solr. Also, you can use stemming and lemmatization if you want to find forms of your keywords. For example, if your keyword is misunderstanding, you will find a text that can contain words understood or something like this. Okay, let's move to semantic. Two people, yes, persons now. What is semantic? Semantic search is something different from traditional search. First of all, semantic search is used to improve your relevancy of your search results, but understanding the search phrase that semantic search can understand a search phrase like a human, and it understands context of your search phrase. Semantic search understands meaning of each keyword in your search phrase and combine these keywords and understand context of your phrase in general. There are some examples where semantic search is used. As Sitecore developers, you should know semantic tagging, how it works. Out of the scene, behind the scene, there exists a big dataset with text, and the search engine can extract the main popular entities from your search phrase and find top terms that used in combination with these keywords. Sitecore out of the box used third-party open client servers, but if you want, you can implement your own. It's not so hard to do. Another example of semantic search is entity extraction. For example, as you can see on the picture, a semantic search can recognize main entities in your search text and also can identify what entity what is. For example, Mona Lisa is a work, Louvre and Paris are some locations, etc. Even you can download open source databases with images, and also you can use any images from your text if you want. A little bit different semantic algorithm is sentiment analysis. For example, you can identify how negative or positive are comments or any part of text. And also the same way you can use machine learning to detect spam in your comments text. It can be useful if, for example, if you have a lot of comments and you don't want manually check each comment before publishing in public. You can use machine learning to help you just. Okay, and word2vec. Word2vec is a very popular machine learning algorithm. It was invented and published in 2013 at Google. It was implemented by Tomasz Mikolov, a Czech developer that works in Google. And what is the main idea of this algorithm? Each word has a numeric representation, and this numeric representation is, the point is in 300 dimension space. Oh, can you imagine 300 dimension space? And what is the features of this algorithm? Two words that have similar context, for example, tea and coffee, will be very close one to each other in this space, and vice versa. For example, table and cat will be far away. Very simplified diagram how it works. As an input, you should have a very, very big data set with text information. And then this data set passes through neural network to layer. And as an output, you will have a vocabulary with word vectors. For example, cat. As you can see, there are 300 numbers that will be coordinated in space. Another word also has 300 numbers that represent another coordinate in this space. For example, if you look in this 300-dimensional space for word apple, it will be very close to word mango and to word Microsoft, but words mango and Microsoft will be far away one from each other. Another great feature that Word2Vec can recognize what part of speech is a word. For example, if you try to find Iron Maiden, the top relevant result will be Judas Priest. And when you find iron, a more relevant result will steel. And if you find, for example, iron pants, you'll find verbs like smooth in Polish. There are also some alternative algorithms like Word2Vec. One very similar to Word2Vec is glove. And there are also two another algorithms, Elmo and BERT. And what is the main difference between Word2Vec and glove and between Elmo and BERT? Elmo and BERT have for one word, like in the picture, one vector for iron noun and one vector for iron that is verb. But Word2Vec and glove combine these 2 points in one and have 1 point with closest relevant results like steel, smooth, and polish together. Okay, a little quiz. Because we represent words like vectors, we can do all mathematics with words like we can do it with vectors. Could you guess what is Germany at airlines? Okay, any other? So, Lufthansa. Okay, the second one, king, subtract man, add woman. Queen. Architect, subtract building, cat, software. Developer, okay. That's all. And the last one, France, subtract Paris and add Minsk. Belarus. Okay. Let's check. a little bit interactive. First of all, let's check how semantic search find closest words to word modem, as was in our example. As you can see, router, Ethernet, DSL, transceiver, wireless, Wi-Fi. It's logic presence. Germany at Airlines. Yes, Lufthansa and stop. Ryanair also presence. And the last one, our quiz. Sorry. King, man and woman. Queen, monarch, princess. Sultan, monarch, throne, royal. Architect, building and software programmer. AutoCAD is very logic also. In France, Paris and Minsk. Belarus is the top. Okay, it's how we can make some operation with words. And what about text? How we compare two texts? It's the same. We represent each text like a sum of words that it consists of, and we'll get as a result one vector. We get to text, pass it through vocabulary that we have from word-to-vec algorithm, and as a result, we will have two vectors and can computate similarity between the texts. How it's computed? It's cosinus similarity. It's like a distance between vectors, but normalized by cosinus, just to have values between 0 and 1. It's very comfortable to use in percentage. 50% similarity, 80%. What about vocabularies? For your solutions, you need a big vocabulary. The famous one location where we can find it is FastText website. That it contains open sources, very many vocabulary vectors. It is Facebook open source, all dictionaries, and also you can have a questions what to do if we have a multi-language website. As you can see, there are many binary vocabularies for 157 languages. And you can download it and use it for your purpose. Sorry, I missed one slide. Just interactive. Yes, it's also interactive. Just a comparison of traditional search and semantic search. How you can guess how much similar are these texts. Cameron wins the Oscar and Cameron wins general elections. As you can see, lexical similarity is very high, 65%, but logically is not so. But semantic similarity is very low. It means that this text are different context, because semantic algorithms represent a text like Cameron wins the Oscar, like someone awards something. And the text Cameron wins general election, it's something depends related to politics. For example, someone become president and prime minister. And the same example, but with another text. Cameron wins the Oscar and all nominees for the Academy Awards. As you can see, semantic similarity is 0. In traditional search, the text will be completely different, but semantic similarity is 72%. And if you use semantic search in your solution, these two texts will be very relevant to each other. You can also try check our example with banana, for example. I see banana. Banana. Sorry. And Bob likes pineapple. Where is where is mistake? Bob. No. Okay, let's skip it. Yes, live demo. Let me show you a modular that we implemented for Sitecore with my colleagues. Evgeny is present here. We implemented a modular related semantic items. By using this modular, we can find items related to context item by semantic search. For example, as you can see, we create a lot of some entities, random. We have the entities that describes some weapons, the entity that describes cars, also some information about notebooks, smartphones, etc. Let's have a look how it works. We have some big text, for example, about Lexus, and we implemented a template where we can choose templates that we want to see as our related results. And we implement these big buttons that run semantic search. As you can see, for Lexus, it finds Nissan, Mercedes, Toyota Corolla, BMW, and Citroën as the most relevant items. And the same for an M16 rifle, it's a gun. Relevant items are M4 Carabin, AK-47, Glock, Z, etc. I can show you how much times it takes to process all 3 with sub-items. As you can see, it's fast. How it works: when we change some text information of our item and save it, we create separate index for storing vectors in Solr, and on each item saving, this recalculation of vectors will be triggered. And all information about our text is storing like float numbers in Solr. We did this index very small, only basic information about item and vector. And demo. Oops. Sorry for so pretty design. For example, article about AK-47. We have a section with related items, and so you can see there are good relevant results like Glock, M16, Uzi, etc. But let's have a look what related items we have for Sitecore. As you can see, related items like Kenti, Combraca, Joomla, BMW X5, M4, Carbine. Have you guessed why BMW and M4 Carbine will get in this related results? Why is they present here? Any ideas? No. Because we have only 3 items about content management systems, but show 5, top 5. Yes, and how can we avoid of seeing these items? We just can define minimum similarity that we can see in our related items. For example, 18% save, refresh. As you can see, they disappear. We can limit it, our relevant results by setting minimum similarity percentage that you can see. Okay, and another one example is general search. How we can use semantic search in like a global search. Okay, we have some items with information about car, about guns, about smartphones. Example like with traditional search, like okay, let's see results about car. As you can see, they are also relevant, like in traditional search. But what if we try to find something that is not related to car, for example, bike? As you can see, also information about cars is top relevant. Drone. Yes. Me action camera. It's top relevant. For example, sniper. We don't have any text that contains this word sniper, but more top relevant results are weapons. But we can add some confusion to our engine, for example, to search sniper vehicle. As you can see, Lexus appears also. And the same, for example, search software architect. You also can see that Umbraco, Kentic, and Sitecore are top, but somehow Asus and Samsung come here. We can also make some settings where we can define minimum similarity of our search results that we want to see, for example, 50%, and the results that have similarity lower than 15% will be gone. So, okay, guys, that's all. Thank you for listening. Maybe.
Did you make use of Cortex in this module?
We integrate it in Sitecore.
Can you explain a bit about your integration with Cortex?
Show you code?
No, just the concept, like how do you make use of Cortex in this?
Like content tagging. Our model is similar to content tagging in 90%.
Okay, so this part of Cortex. Okay, get it.
Any other questions? Vadim?
Yeah, thank you for your presentation. So the first one, you just mentioned at the beginning that you just have been using this Belarusian service food delivery. Yes. And have you tried to suggest semantic search?
No, for our delivery service.
Yeah. Yeah. Yeah.
How?
I don't know. This is just a question.
I will be glad.
Okay. And the technology aspect word you discussed, the search, the mechanism that provided. Yeah, word to vec. And in your presentation, when you just show us in a Sitecore, yeah, so that's in a Cortex. Is it possible to use this approach?
Yes, we use it.
Okay. And the third one question regarding to your quiz.